Hello guys, we'll get started in a minute. I hope you guys can hear me now. Please confirm whether you guys can hear me or not. Can someone from YouTube can confirm whether you guys can hear me? Hello? Can someone confirm? Anyone can YouTube, can you hear me? Okay, thank you. Now I think you guys can hear me. Ashishri, can you please? I think you are a co-host, so you should be able to move the attendees to panelists. So the session is also going on through Zoom webinar. We have invited few people to the webinar, so we are addressing the issue, and then we'll go live very soon. Sorry for the technical issues. It is not expected. I think YouTube have changed some permissions, and I have to authenticate to make sure I can live stream. That's where there is some gap. Let me go to the agenda here. So as part of this session, we'll walk through the details related to trends in data engineering and the program which we are going to conduct under under our guidance. So it is called as guided program on data engineering. We are glad to announce the course. It's a new approach where we'll be teaching. For past few years, I am primarily focused on self-paced on Udemy and YouTube, etc. Now I wanted to take the guided program seriously so that I can build the data engineers for the future. That being said, I'll start with what is data engineering. Then as part of that, I'll talk about what is future related to data engineering, the trends in the data engineering, what are the core skills that are related to the data engineering. Also, when it comes to data engineering, it is increasingly going towards cloud. In future, it will be completely on cloud only. So why data engineering is going to move on to cloud will be covered quite extensively. Also, I'll talk about what are the skills that are required to become a futuristic data engineer. Also, what is the roadmap to become a data engineer irrespective of your current status. Then I'll actually talk about the overview of guided program for students as well as aspirants who are working professionals at this time. So this is the overall agenda. We'll also talk about timelines, pricing, and also free counseling or assessment session for those who are interested to onboard into our guided programs. That being said, let me talk about what is data engineering. So I'll be using this lucid diagram. I hope you guys can see my lucid diagram. Let me zoom out a little bit here. It is too much zoomed in. I think this is better. Okay. If you look at it, when it comes to data engineering, most of the data engineering is being done using something called as Lambda architecture. What is Lambda architecture? Typically, when it comes to data engineering, we build either streaming pipelines or batch pipelines. If you look at this, this is nothing but data sources. This gray rectangle represents the data sources. A data source can be a relational database. It can be files. It can be anything. I'll also get into a few details very soon with a classic example so that you understand what data sources we typically have. From these data sources, either we have to get data in real time in streaming fashion, or we have to get data in batch. If you observe, when it comes to batch, they have a bit thicker arrow compared to real-time processing, because when it comes to real-time processing, we need to have continuous capability, whereas when it comes to batch, we might be running workloads less frequently, but the amount of resources that are required for batch processing will be significantly higher. That's why you see a thicker arrow here when it comes to batch processing. Now, the targets are typically databases or data stores. And there are different types of databases depending upon different scenarios. All those databases or data stores will be used for the downstream applications. So this is the Lambda architecture. Keep in mind that the use cases as part of the data engineering are broadly categorized under either real-time or batch. Now, using this Lambda architecture as reference, I have come up with this general reference architecture diagram, which actually talks about data engineering for any organization. If you look at the center, we have storage or data lake. Those who are in Zoom, you should be able to ask questions at any point in time. I think we are not able to move the attendees to panelists. Let me make sure I move them to panelists so that they can ask any questions they have. In future, we'll be broadcasting a link. Ashish, you can ping the link using which the guys who joined on YouTube can actually sign up for the counseling session. Just ping in the YouTube chat, and then we can take it further. I will also share the YouTube link with you or WhatsApp. You should be able to use it, and you should be able to send the link in the YouTube. You can also pin it so that it always stay on top. Also, you can respond to anyone if someone asks about the link for the free counseling session. That being said, now let's talk about this one, right? If you look at the center, we have data lake and we have distributed computing. As of now, Spark is the technology which is extensively used for distributed computing. Now, these are called as upstream sources. The upstream sources are nothing but traditional RDBMSs. They can be files. They can be even these ones, which are nothing but real-time sources. So these ones and these ones are nothing but upstream sources. From here, data is typically ingested into data lake. As part of the data lake, we typically implement multi-layered architecture for quite a few important reasons. Once you onboard into the course, we'll actually give you quite a lot of case studies, and you will understand why this multi-layered architecture is implemented in the data lake. On top of it, wherever you have to process the data, you need to have compute. As of today, the compute is typically distributed computing. There are multiple technologies with respect to distributed computing. Spark is the most popular one at this juncture. Things might change in future, but Spark is the most popular one at this juncture. So these are the ones which typically used as the intermediate storage as well as computing purpose. So whatever you are seeing here as part of the Lambda architecture in the middle, it is typically implemented using the data lake, which is nothing but storage, and the compute. As of now, it is predominantly Spark. Now, you typically get data from different sources. So I have already mentioned about it. Let me take a classic example. You can pick any popular social networking website or any website, and you should be able to think about what all sources the data might being. Let me rephrase this way. What are all the sources from which data is being generated into the data lake, so that different types of applications based on analytics are developed. So I'll be using something called as runkeeper.com. It is a very simple website, and you should be able to relate easily. Now, when it comes to runkeeper.com, it is both B2C as well as B2B. When I say B2C, I'm talking about business to customer. When I say B2B, it is nothing but business to business. Okay. So when it comes to customers like us, we can sign up for Runkeeper. We can enter our details to build the profile, and then we can start tracking our runs using Runkeeper, right? Once we start using Runkeeper, our runs will be logged into this application, and you should be able to see the trends. It is still loading for some reason. Let me run once again. If it didn't work, I will pick LinkedIn, and even LinkedIn can be used for the reference to understand what types of data sources we typically get data from. Now, if you think about it, there is also premium subscription. There might be people who want to sign up for premium subscription, and you might end up paying for this. And they will take the payments from you, and they will give some additional features than regular features, right? So there are transactions involved, the payments are involved and all. Typically, this data will get into these RDBMS databases. and the runkeeper executives might want to see the details about how many subscriptions are coming, and what is the attrition rate, how many people are quitting on regular basis. All these kind of insights the executives want to see. For those reports, typically we use data from the purpose-built databases, which are typically built using RDBMS databases like Oracle, MySQL, Postgres, etc. On top of it, whenever you run, you might want to ingest the data in real time so that the run-related reports also can be displayed. For example, I use Runkeeper. Lately, I'm not using that much. I'm not keeping track of my walks, but earlier I used to do quite a lot. Let me log in here. Yeah, I think it is asking for all these things. Let me see. Let me try to log in the other window. On my other computer, I typically log in automatically. Here, it did not log in automatically for me. Now, let me bring it here. Okay, you see here, you can see the logs. So these logs are typically called as customer reports. Okay, so there are two types of reports for an organization. One is executive reports, where the users are limited, and the other ones are nothing but customer reports or dashboards. You can also go here. Let me actually go to me here, and I should be able to see the uh, uh, reports for past few months or few years. You can see that I can actually uh, review daily, weekly, as well as monthly. Also, it can be lifetime, or it can be only current year. It can be last 3 months, or it can be last 30 days, right? So these are nothing but customer reports or customer dashboards. So in this case, I am customer, you can be the customer. Also, there might be B2B customers also, where other companies might be customers for this. There are the coaches who are actually customers for this, and they actually onboard their team or their students into this to use it. Okay, so there can be B2B as well as B2C customers. The executives might want to see certain types of reports or dashboards, such as how many people are actually becoming premium customers, how many people are quitting on regular basis, and all. The other types of reports or dashboards are nothing but customer reports or dashboards. So to serve these things, we might want to get these details in real time. Wherever the real time is involved, we use streaming technologies such as Kafka from the sources, and we'll try to get the data into the data lake. So there are two types of reports. One is executive reports or dashboards, which are useful for the which are useful for the runkeeper executives. The second one is nothing but customer analytics or customer reports and dashboards, which are useful to customers like us. So for these two types of reports, we might want to get data in real time as well as batches. Wherever real time is involved, we typically use technologies like Kafka. Wherever batch is involved, we typically use there are different types of tools. It can be traditional ETL tools. If it is AWS, there is a tool called as DMS. It can be used for the data ingestion. Even Spark provides you capabilities using Spark or JDBC. Even using Airflow, you should be able to ingest the data. There are quite a lot of technologies which will take care of ingesting data into the data lake in batches from the databases or files, etc. So once you get the data from purpose-built databases, which actually hold the transactional information and also real-time data, you might want to process the data, and you might want to use this data to serve different types of reports. Once again, I am reiterating, there might be executive reports. Typically for the executive reports, we serve the reports using data warehouses. What are the popular data warehouses? As of today, the most popular data warehouse technology is Snowflake, then Redshift, Synapse on AWS, sorry, Azure. Also, Teradata is also a very popular data warehouse. It used to be top, but now it is one of the top, not the top. So like this, there are quite a lot of data warehouse technologies. So you can use the data warehouse technologies or data warehouse databases to serve the executive reports and dashboards. What are the tools you typically use to see the reports and dashboards? Whatever terms I have used earlier, such as Teradata, Synapse from Azure, Redshift from AWS, Snowflake, these are only databases. They don't have ability to actually serve the reports and dashboards. Typically, we use reporting tools such as Tableau, ClickView, QuickSight, etc., to actually develop the reports and dashboards and also view the reports and dashboards. These BI tools such as ClickView, Tableau, etc., will connect to the data warehouse such as Redshift on AWS, Synapse on Azure, Snowflake, and the reports will be served. For executive reports, where the number of users will be typically in a few tens to few hundreds, this architecture will work quite well. Now, with the modern architecture, the data lake will be used to stage the data. Then the data will be processed. The processed data, which is fine-tuned for the reports or dashboards, is actually stored in the tables in the data warehouse, and the reports and dashboards will be served from there. Now, if you look at this one, it is not practical for Runkeeper to provide reports via Tableau or ClickView or QuickSight, etc. It can be quite expensive, even if these guys charge $1 or $2 per user. It will be very expensive for companies like Runkeeper. And also, when it comes to the reports and dashboards, the characteristics are they are simple reports, but the scalability is the complexity. So it is not practical for companies like Runkeeper to provide customer analytics using traditional reporting tools. They typically build web applications. Data will be served through NoSQL. In some cases, it can be served through RDBMS also. Typically, the reports or dashboards are served via web or mobile applications. You can see a web application here. Even if I look into my mobile, I should be able to see this report or dashboard. When it comes to the data store, a NoSQL or RDBMS database will be used. Once again, the data will be ingested into the data lake in real time or batches. The data will be processed. Then the processed data will go into the NoSQL database to serve these customer reports and analytics. On top of these things, the other use cases are nothing but machine learning algorithms or data science algorithms to understand your data and predict whatever we are interested in. So even this data which is in data lake is served the data science as well as machine learning type of use cases. Now, when it comes to most of the organizations, they typically tend to provide the data to their customers. It can be B2B customers or it can be B2C customers. Typically, the data will be served in the form of CSV or JSON files, or it can be ingested via topic, or it can be through API. So these are also quite popular when it comes to serving the data from data lake to external downstream applications, which are typically owned by some other organizations. So these are typical downstream applications which actually require data. This data lake will actually take care of it. Now, if you relate this to Lambda architecture, the data sources are nothing but the databases, files, the real-time datasets, etc. Then data is typically processed either in streaming or batch processing, and data will be stored in the data lake. So this will actually serve as the middle layer. Whatever you are seeing here, the queries, responses, etc., are nothing but these ones. Typically, here you will be seeing the executive reports or dashboards, or customer analytics reports and dashboards, machine learning or data science algorithms on top of data to get the insights, and also serving the data for the external customers. So this is what data engineering means. This is a very detailed explanation about what is data engineering. Now, what is future of data engineering? The future of data engineering is completely driven by the cloud. Everything will be on cloud. Without cloud knowledge, your profile will be incomplete if you try to apply for data engineering. Already the cloud transformation have started quite a few months back. Most of the customers are getting onto cloud. It's not actually a few months. It's been a couple of years since most of the companies are transitioning themselves to cloud. So everything will be on cloud, and also they will be following multi-layered architecture. it is very, very important to visualize the entire pipelines with respect to data engineering using multi-layered architecture. Typically, the layers are defined as bronze, silver, or gold. Bronze, silver, and gold, or raw, intermediate, or processed. Whether you use bronze, silver, gold, or raw, intermediate, processed, they mean the same thing. Now, when it comes to the development of data engineering pipelines, the trend is towards low code or no code. Okay. However, it doesn't mean that you shouldn't be having, or you can ignore programming skills. These tools which are being provided to you complement your programming skills by making you focus on more and more business logic rather than the nuts and bolts around the pipelines. Okay. And unless and until you are comfortable with coding, you will struggle quite a bit. It is important for you to have decent programming skills. You don't need to be expert with when it comes to programming, but you should have decent programming skills. So the trends with respect to data engineering is towards low code or no code. Now, I will also talk about what are the core skills when it comes to data engineering. The most important skill is SQL. When it comes to data warehousing, the SQL is the core skill even today with respect to data engineering. In my opinion, SQL is the most important skill, followed by programming using Python. Actually, in between, probably SQL and cloud I prefer both of them at equal level. So you have to make sure you have decent SQL skills. Also, you have decent cloud skills. Then you have to have programming skills using Python. Python will be the standard programming language for data engineering. You can also use whatever programming language you're comfortable with the trend we are getting into, but wherever you have to code for new applications, typically we'll end up using Python than other programming languages. And then you also should be familiar about orchestrated pipelines. Okay. There is a question from Abhijit. He's asking why we need a data warehouse. Can't we connect BI tools from data lakes? See, even data lakes are terming themselves as data warehouses only. And data warehouses are better built for reporting purposes. And data lakes, and actually, even data warehouses such as Redshift, they're slowly transitioning into serverless. So that fine line between data warehouse and a data lake will be erased very soon. But still, as of now, they are making sure that data warehouse technologies are relevant. So one of the user in Zoom chat have asked why we need a data warehouse. Can't we connect BI tools from data lakes? It's a very good question. As of now, data lake is serverless, which means you only have to worry about storage when it comes to data lake. Whenever you want to process the data, you get the resources leveraging cloud and process the data. Then you should be terminating the resources. Okay, that way you will be paying only for storage, not for the compute. Now, the question is valid if the data warehouse technologies such as Redshift or Synapse or any other technology doesn't have serverless capabilities in them. Already, most of the customers are using Redshift or Synapse or SQL Server, or there are quite a few other technologies as well. So what those data warehousing tools are doing is they are making themselves as serverless, which means the existing applications will not be impacted anymore. They can still use the existing applications, and hence, when it comes to data warehouse technologies such as Redshift, Synapse, etc., they will survive. They will not go away. Even Snowflake is one of the serverless data warehouse, one of the first of its kind serverless data warehouse. Now everyone is trying to emulate it. Already Redshift have launched something called as Redshift serverless a few months back, and hence the data warehouse will stay. They will complement the data lakes, and however, they will only stay if they're serverless. If they are not serverless, then they will cease to exist. They will not exist. To answer your question, the fine line between the data warehouse and data lake will be slowly be erased. Okay. I hope I answered your question, Abhijit. Now, let me, already I think I have answered about why data engineering on cloud. Okay, there is a question from YouTuber. I will take that question at a later point in time. It is a good question as well. Just give me a few minutes. I will answer that question. So now let me answer this question. Why data engineering on cloud? One of the key features is when it comes to cloud, you just have to pay when you use it. If you don't use it, you don't need to pay. So the setup costs are low. You just have to pay wherever you use it. Otherwise, you don't need to. That's why more and more people are actually going towards cloud. Already the data engineering pipelines are actually being built on cloud only. Okay. Now let's talk about roadmap to become a data engineer. So when it comes to becoming a data engineer, if you are completely new to IT industry, you have to make sure you focus on SQL and Python. These two are the things which you can focus on. Then you have to learn AWS or any other cloud platform. It can be any other cloud platform, but I still prefer AWS over others because it is a lot more matured compared to GCP or Azure. Slowly they'll catch up. If you focus on AWS, you will be ahead in game. You should be able to adapt to the other cloud platforms also, and you should be able to work on them as well. If you are already a working professional, if you are from a Microsoft technology background or GCP background, then probably you can, or Google background, then probably you can consider the respect to cloud. But if you are completely new, I would suggest you to get into the AWS after learning SQL and Python. Earlier, I have said that SQL and cloud are more important, followed by Python, right? Now, why I should learn Python and SQL to begin with before getting into cloud? Because when it comes to cloud, sometimes you might have to code. Python is a very good programming language to interact with the cloud. In AWS, we have Boto 3, or for AWS, we have Boto 3. Using Boto 3, we should be able to take care of interacting with the cloud. And once you start interacting with the cloud using programmatic approach, you can leverage the cloud much better. So even though Python might not be as important as SQL and cloud going forward, still I would highly recommend you to start with Python and SQL, be comfortable with those things, and then get into the cloud. Then you can actually focus on other skills. Primarily, instead of going through technologies like Spark and spending too much of time, you should focus on how to build orchestrated pipelines depending upon the requirements. If it is AWS, you have to focus on Lambda functions, then EMR, then Redshift. These are the technologies you should focus on. You don't need to deep dive into Spark unless and until it is really important for you. You just have you just have to focus on building the solutions for solutions rather than just focusing on one specific technology. Also, if you think about it, if you are familiar about Python, Python have pandas. Spark is another module like pandas. There is nothing fancy about Spark. Okay. As of now, it is hot, but eventually Spark will be one of the key modules when it comes to building the data engineering pipelines. There'll be at least 60 to 70% of the work which will be going in the direction towards sorry. When it comes to data engineering work, 60% to 70% of the work will be outside of Spark. Okay, so there are quite a few things which you need to learn when it comes to building pipelines. You should focus on building pipelines. In that process, you can pick Spark as and when it is required. And then you have to focus on how to visualize a solution for a given problem and use appropriate technology and take it further. So Python and SQL to begin with, then cloud, then learn Spark, try to build end-to-end pipelines while learning all the key services in AWS. I'll also walk you through what are those services in AWS you should be focusing on. Before going further, let me answer this question. What is the difference between, okay, someone is asking about the difference between this course and Udemy course. I will talk later. First, let me answer this question. It is from Sudipto Chakrabarti. The guy is asking, in place of Python, can we learn Scala for data engineering? I don't think Scala will go very long. The first place will be occupied by Python. I don't think it will be replaced from Python, replaced by any technology anytime soon. Most likely, the second place can be occupied by Java than Scala. I will explain why Java can be a second placeholder after Python, and Java will be very distant second placeholder, not a close second placeholder. I will explain that in a moment. When it comes to Scala, even though Spark is developed using Scala, Scala is not that important going forward, because whether you write code in Scala or in Python, when it comes to the performance, almost for 90 to 95 percentage, the performance will more or less be same. And Python is a lot more easier to learn, and also there are quite a few advantages when it comes to Python. I'll give a quick demo so that you understand why Python is significantly more prominent than Scala. Okay, so let me log in into my AWS account. Now I am logged into my AWS account. Okay, so if you look at this, there is something called as step functions using which you can build the orchestrated pipelines. You can also visualize Airflow in place of step functions, and you should be able to build orchestrated pipelines. When it comes to Airflow, it is developed using Python, and you can actually add more and more logic using Python easily in Airflow compared to other programming languages. Same is the case with step functions. So step functions are very well integrated with Lambda functions in AWS. Even Airflow have a very good integration with Python as programming language. Now, if you have to build any custom logic to customize your pipeline, let me give a classic example so that you understand what I'm talking about. Okay, I'll be walking you through one of the pipeline which is being built using EMR. Let me see what is that. I think this is the one, GH activity file format converter. Let me go to edit. Okay, so now this is nothing but something called as a step function in AWS. And keep in mind that you will be learning building these kind of pipelines as part of the guided program course. Okay, you will be very comfortable in building these pipelines, and we'll be providing you the support as well. Now, if you look at this, this step will take care of creating EMR cluster. Even if you think from the Airflow perspective, you can create a DAG, a component or a node in the DAG, which actually take care of creating the EMR cluster. This step will actually take care of deploying the Spark application on EMR cluster. This step will take care of terminating the cluster. Now, let's say I would like to add additional functionality to see if the files exist or not before creating the cluster, adding the Spark application as step to the cluster, execute it, and then terminate the cluster. If you have to use Scala as programming language, there is no easy way to plug in into this step function. Okay, it will be quite a lot of cumbersome task. Now, without touching the core logic, no matter this Spark application which is deployed as a step function is built using Python or Java or Scala, it doesn't matter. Okay, you don't need to touch this at all. Then you can use either Airflow or step function or any orchestration tool, and you should be able to build required logic to do the validations. If you look at this, in this case, I am checking if the location from which I wanted to get the data by my Spark application have all the required files or not. If I have the required files, then only go ahead and run it. Also, if the target location where this Spark application is going to write contains the files, then I would like to delete the files. Even that logic is there here. If you look at it here, it is actually checking for objects. If source already have the data, then I'm saying is ready. Then it will take care of validating S3 target. If the target already have the files, it will first delete the files, and then it will go to the task of creating the cluster, processing the data, so on and so forth. Now, why I'm talking about this? You see here there is something called as Lambda function to see if the source have all the required files or not. Now, when it comes to AWS Lambda functions, or even if you wanted to use Airflow, if you wanted to develop a functionality, you can use inline Python code. Even in this case, if you go to the Lambda function, the Lambda function which is used is nothing but, I think this one, let me see, is ready to process. I don't think this is the one. The package type is simple one. Yeah. I think check source S3. Let me see. Yeah, this is the one. So just this piece of code will actually confirm whether the source have the files or not. Okay. Ashish, can you start responding to some of the questions that are being asked in YouTube? That being said, using this piece of code, simple piece of code, I am able to take care of the validation. If you think about implementing this in Scala, it is not very straightforward. If you have to plug in, you have to develop a class, and then you have to compile into a jar file, and then you have to deploy the jar file. It is not as simple as this. On top of it, when it comes to Lambda functions, if you want to create new Lambda functions, even with respect to Python also, the complexity is same. If you want to implement that logic in, if you want to implement this pipeline in Airflow, if you have to plug in something in between using Scala, it will become quite cumbersome. Whereas here, it is very straightforward. If I try to create a new function, if you look at the runtime, as of now, Scala runtime is not even available here in AWS Lambda functions. So for all these practical purposes, the usage of Scala will go down considerably. Why I'm saying Java will take the second place is because there are enough Java developers in the world compared to Scala developers. Instead of implementing the core logic of the pipelines in Scala, some companies are preferring to use Java. I have heard from quite a few senior directors in leading banks, retail companies, etc. They are actually focused on Java than Scala, if not Python. Okay, so the first place will be Python. 70% of the data engineering applications, if at all coding is required, will be taken care by Python. Then probably 15% Java, anywhere between 2 to 5% will be Scala in future. Okay, so if you are a Scala-based data engineer, it is time for you to move on to Python. Make sure you learn Python and be prepared using Python as a programming language. Abhijit is asking follow-up question whether step function is similar to Airflow. That is right, Abhijit. Step function is similar to Airflow. It is primarily to build orchestration pipelines. The difference is Airflow is open source, whereas step function is AWS native service. Okay. Now, I have covered enough when it comes to roadmap and also the skills. As of now, we are primarily focused on the AWS-based data engineering program. Eventually, we will release other programs as well. What you will be learning when it comes to AWS-based data engineering program, let me actually expand services here. You see there is something called as analytics. If you go to the analytics, there are quite a few of them. We will not be covering everything. It will be simply overwhelming for you. But whatever are more prominent and whatever are essential will be covered. So we'll be focusing on Athena, which is nothing but serverless query engine. It is quite extensively used for ad hoc analysis of data without worrying too much about setting up EMR cluster or Spark cluster. You can actually go to Athena query editor and you should be able to perform analysis using Athena. On top of it, we'll also focus on EMR. EMR is the one which you typically use to build applications using Spark. With a no-code or low-code approach, the only areas where you will be using EMR is primarily to integrate with NoSQL databases or data warehouse databases. Other than that, if everything is within data lake, there is no need to use Spark. You will be using EMR, but you don't need to code using Spark APIs. There is also Spark SQL. you should be able to build the pipelines using Spark SQL, and you should be good to go. Let me show you one thing here to make sure you understand what I'm talking about here. EMR is nothing but Spark-based engine. Even though it is Spark-based engine, you don't need to develop Spark applications to use EMR. Okay, and this is the cluster which is still running. I think I don't think this is the one where I have tested that. Let me see. Yeah, this is the one. If you look at this, right, this is nothing but a Spark SQL query which have ran successfully. Let me show you the details. So I have copied a Spark SQL script into S3, and I have invoked that script. Whatever is there in that script is executed successfully. So for all the data processing between bronze to silver to gold, you don't even need to develop Spark-based applications, even using Python as a programming language. Leveraging Spark SQL, you should be able to build the pipelines. There is a popular open source SQL-based tool also, which can work with any SQL-based engines. That is nothing but DBT. Tools like Airflow can be integrated with the DBT. And even if you are not using technologies related to AWS, still you should be able to build pipelines using Airflow and DBT without writing too much of code. So the trend is towards low code or no code. The only area as of now where you have to write code, even using Python, leveraging Spark, is primarily to get data out of the data lake into data warehouse or NoSQL or RDBMS. Only in those scenarios you have to write. Even with respect to data warehouse also, it is getting smaller and smaller effort when it comes to writing any Spark-based applications. Only when it comes to writing to NoSQL, you might have to use a Spark-based code. Otherwise, you don't need to write Spark-based code. But that doesn't mean that you should not be knowing Python, or you will get away without knowing Python. You should have decent knowledge about Python. Okay. So that is about EMR, why EMR should be learned. Now let me go here. Okay. Not this one. Yeah, this one. Now if I go to services and if I click on analytics, Athena is important one, EMR. Then Glue, as part of Glue, there are quite a few components. We'll be primarily focused on Glue catalog only. We'll not be focused on Glue jobs and all. The reason why we'll not be covering Glue jobs and all is because it will make your applications cloud native. And as of now, the trend is they don't want to use too much of cloud features. Glue will actually make your Spark applications more and more dependent on AWS. If you avoid Glue and if you build your Spark applications for EMR, if not AWS EMR, you should be able to deploy those Spark applications on Databricks or GCP Dataproc, wherever you want. For that reason, people don't want to use Glue. Rather, they want to focus on EMR-based approach. Even though Glue is a Spark-based engine, it's not open source. It's actually a customized version of Spark. It will lock in the customers towards AWS. That's why people are not preferring to use Glue. Even with respect to EMR also, there is something called as serverless EMR. As of now, the trend is towards serverless EMR. And we'll be focusing on even serverless up to an extent as part of our course. On top of this one, we'll also talk about Kinesis. Also MSK. MSK is nothing but Kafka. On top of these things, we'll also go towards Redshift. You will learn Redshift. On top of these key AWS analytics services, there are other services which are very, very important for you going forward. They are nothing but step functions to build orchestrated pipelines, and also Lambda functions. Focusing on only step functions and other services will not be good enough unless and until you have a bit of decent idea about Lambda functions. We'll also make sure that you are comfortable with Lambda functions. On top of these things, the data lake is typically built on S3. You should be familiar about S3. S3 is one of the essential skill with respect to AWS, and hence you have to know S3. Also, you have to focus on IAM for authentication and authorization. IAM is the approach where the permissions are granted between all the services and also the users and the AWS services. So there will be enough material on IAM. On top of S3 and IAM, we'll also talk about step functions, Lambda functions, etc. So these are the skills which will be taught as part of the overall program. The program is divided into 8 to 9 courses. In these 8 to 9 courses, you'll be learning how to build end-to-end pipelines using all these technologies. Okay. So that being said, now before getting into the details about the overview of the program and also timelines and pricing, let me take few questions here. There are a few questions in the pipeline. Yeah, there is a question from Logs about GCP. Yeah, as of now, we are primarily focused on AWS. The next program will be on Databricks. Then we are planning to focus on Azure and Snowflake. GCP probably will be the last option. It might take around a year for us to come up with the GCP related courses. We'll be primarily focused on AWS, Databricks, Snowflake, and Azure in coming months. Okay. So that being said, I think there are no more questions. Yeah, this is not the right forum, Abhijit. Yeah, once you get into the course, if you have questions about SQS and if you want to learn SQS, we will give some guidance over there. But as of now, SQS is not that relevant because it is not very popular when it comes to the data engineering. For microservices and all, it is quite popular. But for data engineering, we typically use Kinesis or Kafka compared to SQS. Okay. However, you can add those skills also. There is no harm. Definitely your profile will be elevated. Now let's go to the details about the course. Okay, there is a question on what level of Python and SQL needed. SQL, definitely you have to have very good in-depth knowledge. You need to understand basic SQL queries. When I say basic, I'm talking about where conditions, group by, which are nothing but aggregations, joins, all types of joins. On top of these things, you also need to be very familiar about analytic functions and windowing functions. Also, you should be focused on how to process JSON data using SQL. As of now, our Udemy courses and all doesn't have all these details with respect to processing JSON data and all, but as part of both Udemy as well as our guided program, we'll be including quite a lot of details with respect to processing data using SQL. Okay, so SQL you should know almost in and out, especially from the data warehousing perspective. It includes writing a very complex SQL query, joining tens of tables. It can be few tens of lines at regular intervals. When it comes to Python, you should have a broader knowledge about Python. You should be focused on Pandas. Pandas is one of the key technology which you should be learning, and also Spark. These are the key modules in Python. Okay, then yeah, I think I have answered the question about what level of Python and SQL you should be knowing. Definitely SQL you have to know in and out. Python, broader knowledge, and then having a decent knowledge about Python and Spark, sorry, Pandas and Spark. Also, you should be able to come up with solutions using Python as programming language based on the requirements. And also when it comes to integrating with external applications, you should be very comfortable using Python. Okay, all those things will be covered as part of the course. Yeah, Ahmed, all those skills will be added in our program. There will be quite a lot of Python. I want to answer one. I want to make one point here. So if you are a fresher, I would highly recommend you to spend at least 2 to 3 months of time to master Python. SQL also, it might take 6 to 8 weeks. Once you learn Python and SQL, then only you should focus on AWS and other technologies. If you are already a working professional and if you are comfortable with programming, or even if you are comfortable with traditional ETL, instead of spending too much of time on Python, you can directly jump onto AWS after scratching the surface of Python. Start working on building the pipelines. In that process, you will be learning Python. Once you are done with learning the key skills in the by building certain pipelines, then you can focus on Python from the interview perspective. Okay, as a working professional, it should be easy for you to focus on building the pipelines and focus on Python from the interview perspective rather than spending too much of time on Python itself, which will demotivate you and you might end up giving up in between. Okay, so that is for freshers versus working professionals. Now, someone have asked the question about if I enroll with this course, how do I relate that with the GCP? So there are quite a few things which are common. For example, Python. If you are not familiar about Python, you will be learning Python. You will be learning SQL. I think almost 60 to 70% there will be overlap. But when it comes to interacting with the GCP services, if at all it is required, it will be different. Other than that, building end-to-end pipelines and all will be similar in nature. Okay, so definitely there will be some contrasting differences which you have to fill the gaps over a period of time. But you can actually get started with this, and then you can actually switch over to GCP. Even learning how to build pipelines in GCP will become a little bit easier, and also your horizon with respect to getting the jobs will be widened if you know both GCP and AWS. Okay, so there's one more question in YouTube: among Azure, GCP, and AWS, which would be best for data engineering in coming time? Very good question. AWS will be the top. I don't think anyone can replace AWS anytime soon, followed by Azure, because Azure have a strong footprint in enterprise world compared to GCP. Then third will be GCP. Okay, and most of the enterprises want to have their workloads at least in two platforms, and hence all the three cloud platforms will play a critical role. If you think about the retail industry are not comfortable in deploying their applications on AWS, because AWS is a direct competitor for all the retail companies, right? So they don't want to get onto the AWS. They want to use other platforms. So they will go with Azure and GCP. Some companies will use AWS as primary, GCP as secondary. Other companies might use AWS as primary, Azure as secondary, or even vice versa. But AWS as primary, the number will be much higher compared to others. Okay, so there is a question from Priya, very good question about H4 EAD and no IT background. Will this course help me to get the job in US? What kind of support will be provided? So Priya, we will invite you to one-on-one counseling session or closed counseling session where we can clarify all your questions. We'll also assess you whether data engineering is the right choice for you, or you wanted to go with some other lightweight roles than data engineering, such as BI developer, data analyst, etc. Then you can make the call. Okay, it is a bit broader question at this juncture, and without me understanding you, I will not be able to answer that question. Okay, so there's a question from Srini. Yeah, let me get into the program details. Then you will understand the Srini's question will be automatically be answered. The question is, what about the timing for North American locals? So first, let me walk you through the program. So the program which you will be going through is nothing but this one, data engineering using AWS Analytics. Okay, so you'll be learning AWS Essentials, as I have mentioned to you. Then mastering AWS Lambda functions for data engineers. Then we also have Elastic MapReduce or EMR, Redshift, and also AWS Glue and Athena. Also, we have a couple of other courses in pipeline around Kafka and Kinesis. Okay, so these are the topics which you will be learning. When it comes to the content will be self-paced, which means we'll be giving you all the video lectures and all, but we'll be providing continuous support. So these programs are supported by expert data engineers who are working in companies like T-Mobile, Albertsons, and also Vimeo. A proven set of data engineers will be leading the effort of the support, and also this is supported by my another company. So there will be support from my another company professionals also, so that your questions will be answered as quickly as possible. Even though IT University is going to run the program, I run another company called as Analytics as a CTO, where we will be providing data related services. That company professionals also will be involved when it comes to the support. Now, when it comes to the timing, on top of continuous support through our LMS, where you can ask the question and we'll respond, we'll also have live sessions, at least 2 live sessions in the nights of US time, and three live sessions in the mornings of US time. So almost every day you'll have 1 live session. You can come on board and you can get your questions clarified in case of any concept level questions are there. If it is just technical related questions, you can directly post the questions as part of our LMS, and we'll respond to you in timely manner. Someone asked me the difference between Udemy course, the existing Udemy course, and this program. The existing Udemy course is predominantly on Python, SQL, and Spark, which will give you some, not some, but the most essential skills. Whether you are working on cloud or not, whatever is required are covered in that. Not much cloud related information is there. However, we have started publishing all these courses on Udemy also. So there will be 8 to 9 courses in Udemy. Each course will be in the range of $30 to $50. No matter whether you sign up for Udemy or this one, and the cost will be more or less same, but by signing up for our platform, there will be some additional benefits. With Udemy, there will be limited live support, whereas with this one, there will be continuous live support. Okay, so we'll be responding to your questions through our LMS, and also there will be a lot more live sessions in when it comes to these guided programs. We'll be addressing your queries as part of these programs. Also, we provide limited job assistance. We will review whether your profile looks good or not, whether your LinkedIn profile is sounding as a data engineer or not. Also, we'll walk through the case studies so that you can relate whatever projects you are going to execute as part of the training to the experience you have in the past. And also we'll help you in a couple of mock interviews. So there will be some limited job support for you. These are the additional advantages if you sign up for the course using our LMS over Udemy. Okay, so I have answered both the questions about what all will be covered, and also what is the difference between this and Udemy, and also have answered the question about the timings. So the content will be self-paced, but there will be continuous support to clarify your doubts. Okay, then there is a question. I think all the questions are answered. Let me see if there are any questions in the live chat. Yeah, so there's a very important question from RGV. RGV, even last name matches. And that's, I don't know whether you are misleading us or whether it is your
I'm not
real
misleading.
name. Anyway, I will call you as RGV. So there's a question from RGV. It says, can we know the duration of the course? So we are dividing this course for part-time and full-time. If you are a H4 EAD and if you wanted to take the program full-time, or if you have just graduated from the college, and if you wanted to take the program full-time, you'll be getting 9-month access for the program. 8 or 9 months, I do not remember on top of my head, but definitely it is 8+ months. Okay, that is full-time program. When it comes to part-time program, it will actually be given to you up to 14 months. It can be extended by more months depending upon the situation of the student who signed up for the part-time program. If it is working professionals and if it is part-time, they will be capped at 14 months. But for students who are still pursuing masters, if they do not graduate within 14 months, we might extend beyond 14 months as well. As of now, we are giving 8-month access for full-time and 14-month access for the part-time program. Okay, so these are the timelines. Most likely, if you spend full-time, you should be able to get the required skills within 4 months if you start from scratch. However, if you're already familiar about Python, SQL, etc., I can actually groom you within a month. You can be job ready within a month, and you should be able to start marketing yourself, or you can ask your employer to market you, and you can take it further. This is primarily for the students who have some level of Python and SQL knowledge, and also prior IT experience, Again, all these details will be covered as part of the counseling session. Feel free to sign up for the counseling session and we will take it further. Okay. So that being said, now let me actually talk about pricing. Okay. So the pricing starts at $400. If you don't want to learn Python and SQL, if you just want to learn all the key services in AWS, it will be $400. Okay. There are bulk discounts. So if you people group together into 3 to 4 people, we can consider for bulk discounts and we can offer bulk discounts. Then if you also want to learn Python and SQL on top of all the AWS essential services, then it will be $480. Okay, Python and SQL plus AWS analytics will be $480. Discarding Python and SQL, it will be $400 for working professionals and also the H4 EADs, all those guys. Okay, those who are actually pursuing masters or who have graduated recently, we are offering a special price to them. It will be only $300. Okay, so this is the cost, $300 for students who are still pursuing masters or who just graduate recently or who are going to graduate in August. Okay, it is only $300. However, on top of $300, once you get the required training, in case if you need placement assistance, where we'll be working with you very closely by building your profile, by getting you prepared for the interviews, by conducting several mock interviews and all, there will be additional costs for that. But for just a training, it will be $300. Again, RGB is asking question about people in India. So when it comes to India, the cost will be more or less same, $400. It will be close to that amount. We will give some discount. We will get back to you on that. You can actually join for, you can come on board for the live counseling session. We will discuss depending upon your current situation and we can take it further. Ashish, can you ping the link to the form so that these guys also can fill? If you have already filled the form, which we have circulated earlier, we will follow up with you and we will ask you to register for live session. We will share our window and we'll take it further. So there will be multiple windows for working professionals, multiple windows for graduates. So depending upon your current situation, you can sign up for that window. We'll group the people who are related and we'll conduct the counseling session. Okay. Priya, Ashish will actually share you the link. You can fill your details in that so that you can get the details related to the live session. Okay. Then let me see if there are any other questions. Yeah. So someone is asking about timings. Timings will be in Indian timings. It is 8:30 to 9:30, couple of days in the evening, and also 6 to 6:30 on 3 days. So in the evening you will be having 5 sessions. It is 8:30 to 9 on Tuesday and Friday, 6 to 6:30 on Monday, Monday, Wednesday, and Thursday. In the mornings, the sessions are on Tuesday and Friday India time, which is Monday and Thursday evening time in US. The timing is 7 to 8 a.m. India time. Okay. I hope I gave the timings, Amar. You can also sign up for the live session, and if you're still confused, we will clarify that. We'll also publish the details as part of the course. Ashish, make a note of it and make sure the timings are broadcasted as part of the landing page. Okay. That being said, will there be any support? Okay, there are a couple of questions around certifications. One is about covering the certification. We'll be covering the curriculum of Databricks certification. You can actually give the Databricks certification with confidence. Even though we started just recently, almost I heard 40 people or 30 people cleared the certification. Within our organization itself, 10 people cleared the certification. outside also, I got quite a few acknowledgements about the certification from Databricks. If you want to prepare for the certification, you will get all the required material and support with respect to Databricks certification. The second question is, do we need to do any certifications other than this course? It all depends upon your personal choice. As I have mentioned to you earlier, Spark will be one of the component. It need not be the complete component. Probably AWS Big Data Specialty certification can add some value to your profile, or any other cloud platform data engineering or analytics certification can add value to you. But I don't think, because there are so many moving parts, certification will get you important knowledge here. You will be simply be overwhelmed. I have gone through AWS Big Data Specialty certification. You have to unnecessarily remember quite a lot of stuff, which is not required when you get into the actual projects. I feel it might become counterproductive if you try to give certifications in this area, because of too many services that are involved. But it's up to you. If you want to give the certification, you can give. We will give enough skills to actually build the pipelines and face the interviews confidently. Okay. Yeah, another very important question about lab. So we'll be providing lab access. You will be able to you will be able to learn Python, SQL, Spark, etc. using lab. On top of this, when it comes to AWS, you have to spend from your own pocket. We'll not be providing the lab for you. More or less, it might cost you around $20 to $30 by the end of the course, unless you make a serious mistake where you end up wasting resources. You should not be charged more than $20 to $30. Okay. So those are the details about the timelines, pricing, etc. There are quite a few important questions. We'll go to this chat and we'll also build FAQs and we'll try to publish as part of the future sessions. For now, thank you very much for asking all these very, very important questions. Okay. So that being said, we are also trying to get endorsements from key people in the industry so that it gives weightage for the curriculum. As of now, we are still working on it. We are a little bit overwhelmed because I'm primarily focused on courses. I myself have some credibility. That's why I'm not very focused on getting endorsements. But in future, we'll definitely get some endorsements from the companies. And also, we are trying to build the client base so that we can provide the placement support also eventually. As of now, we are not focused on placement support, except for preparing you for the interviews. But eventually, as we grow together, we'll build the capability to market you guys in our network so that you get jobs quickly. Okay. So that being said, that's it for now. I thought of walking through another deck, but we spent almost more than 1 hour on this itself. Probably I will I will broadcast another video which actually talk about the program in detail, and also as part of the live sessions we'll be talking about not live sessions, as part of the counseling sessions we'll ask more relevant questions to understand you better, and we'll give proper direction so that you can take it further. Okay. Karan, I don't think we understand the question. If you are expecting the lab using AWS services, we are not going to provide the lab on AWS services because it is quite expensive. But Hadoop, Python, SQL, Spark, all of them can be practiced on IT labs. You will be getting the lab access for the duration of the course, depending upon the course which you sign up. Whether you sign up for full-time or part-time, depending upon that, you will be getting that much lab access. But we will not be providing lab access for the AWS. You have to spend money from your pocket. Only area where you might end up spending money is EMR. Again, EMR also getting into serverless. More likely, once it goes to serverless, you might not wasting too much of money on EMR. One of the caveat about EMR is even today, there are features where EMR can be auto terminated after certain amount of idle time. But setting up EMR again and developing the code against EMR and all can be a bit counterproductive. If you end up keeping EMR cluster for a little bit extended period of time, you will end up spending quite a lot of money. Once EMR serverless mature enough, probably you will not be spending too much of money even on EMR as a learner. Apart from EMR, it will hardly take $10 to $15 to go to the entire course. Redshift also have the serverless. Kinesis, Kafka, all these are serverless only. Depending upon the amount of data you ingest, you will end up paying. For building the pipelines, validating the pipelines, you will not be spending a huge amount of money for the labs on AWS. I'll be surprised if it crosses $50, unless there is a serious mistake from your side. Okay. Okay, then thank you very much, guys. Feel free to like if you like the content, and also feel free to provide a comment if you want to leave a feedback about this. If you are from Udemy, make sure you provide us the rating on the Udemy courses. It is very valuable to us. As we are mentioning, in case if you want to have a close-knit live session when it comes to your when it comes to counseling and deciding whether data engineering is the right path for you or not, feel free to sign up using the link that is shared. We'll definitely have a live session with you. Then we'll take it further. That being said, have a nice rest of the weekend. Thank you. Bye.